Using the discriminant. What is the discriminant? It's just part of the quadratic formula, so it's not like you're learning something new here. You're just learning to use something you already know to tell you something that you might be interested in. So that's just the part that's underneath the radical in the quad formula. And if you have a standard form of a quadratic equation, or you have a quadratic equation you can get into standard form, you're going to be able to tell something about the graph of that equation by just plugging in A, B, and C and doing that little bit of math. So you could have something like this where you have no real roots. Right? Real roots are your x-intercept. This parabola does not intersect the x-axis, so it has no real roots. You might have something that has one real root. Those are perfect square trinomials that get you that. They're the ones that sit on the x-axis. This one just has one real root. Or you might have, let's make that straighter. You might have two real roots. And just by plugging in A, B, and C and doing that little bit of math, you can tell which one of those situations you're going to have. And I'm going to write it out here, and then we'll do some examples. So what if the discriminant is less than 0? That's when you have a negative discriminant. That's when you're doing the quadratic formula, you have a negative under the radical, or if you complete the square, you have a negative under the radical. That's when you have no real roots. You have complex roots. We've seen that. They have i's in them when you simplify them. When this results in exactly 0, then you have one real root. Right? 0, when that's its value. You have one real root. That's when you have a perfect square trinomial. And then the third option, third possibility, is when you have the discriminant is greater than 0, basically any positive number, then you have two real roots, and it has two x-intercepts. So we've been saying that it's possible for quadratics to have no real roots, or one real root, or two real roots. And now we know that that's tied to the discriminant. And let's put up here, since we're in Algebra 2, when we say no real roots, that means it has two complex roots. Right? That's kind of important. Thought I was teaching Algebra 1 for a second there. So when it has no real roots, it has two complex roots. Here we've got x squared plus 10x plus 32. When I look at that, I get a is 1, b is 10, c is 32. I'll do this one with all the detail. The next ones I'll do a little more quickly. So I'm trying to do b squared minus 4ac. So I just plug things in and do the math. B squared minus 4 times a times c. 32 times 2 is 64, so this is 128. So I get negative 28. Well, since I get a negative number, that's all I really care about, right? If it asks me to evaluate or give the value of the discriminant, it's negative 28. If they ask me to give the value of the discriminant, it's negative 28. Usually we don't care about the exact value. Sometimes they'll ask you, but that's usually just when you're learning how to do it. That's kind of a baby step. The reason we care about the discriminant is we care that it's negative, and the fact that it's negative means there's no real roots. There's 2 complex roots. It's not going to hit the x-axis ever. And if we did a quick graph of it, you'd see what it looks like. That's what the graph looks like. You can see how it just doesn't ever hit the x-axis. Here's one. Similar, a little different. Again, I'm just going to go ahead and jump straight to b squared minus 4ac, b squared minus 4ac, 100 minus 100. Oh, that one's 0. So again, this is the value of the discriminant, but our big important thing is it's 0, so there is 1 real root. Okay, and there you can see what a graph of that would look like. And you can see that it's the kind that just bounces off the x-axis or sits on top of the x-axis. The last kind, I'm trying to get you some that you might not have factored or you might not have graphed because they're kind of biggish numbers sometimes. And so b squared minus 4ac, b 4ac, so we've got 16, negative times negative, so positive. Okay, that's an awfully big value, but all I really care, usually, again, I might be asked the value. If I'm asked the value, that's what it is. But all I really care about is that it's positive, so that means it has 2 real roots. And we could factor them to easily find it, but there's a quick graph just to show you what that looks like. So I kind of did each of them in order. I'm going to give you 3 to do on your own. Give it a try. Mix them up for you. There's 3 for you to try on your own. Pause the video, give those a try on your own, come up with some answers. So my value is 25. That means it's positive. So I have 2 real roots. This one ends up being negative. When it's negative, I have 2 complex roots. This one ends up being 0, and so it's got 1 real root. And there's all the graphs. You weren't asked to graph it, but just want you to get that connection of what we're talking about.